is Unit 12, Lesson 2, Permutations and Combinations. And in this lesson, we're going to determine, first of all, if something is a permutation or a combination, and then we're going to solve them using some formulas. In a permutation, order matters. That's the big thing you need to understand. So if you have a situation where the order of the numbers or the order that you decide on things matters, it is a permutation. So an example of that is like if you're giving prizes of a different value, whoever came in first would get the highest valued prize, second would get the second highest valued prize, and so forth. If you're electing officials, of course, president is more important than vice president, and that's more important than secretary, and so on. Contest winners, first, second, third place. If you're running a race and you get first, well, you don't want the bronze medal, you want the gold. So the order in that matters. If it's a combination, order does not matter. And I like to say it like this. If I have a fruit salad and I'm putting apples, pineapple, and oranges in that fruit salad, well, it doesn't matter whether I put in the apples, oranges, or pineapples first. If I put in the same ingredients and stir it up, it's all going to be the same anyway. So with a combination, order does not matter. So for example, a real life example of that is if you're drawing several names out of a hat for the same prize. Well, it doesn't matter who's drawn first. They all get the same prize. So order doesn't matter. If you're choosing anything at random where there is no one more important than anybody else, that would be an example of a combination. You will be asked to determine how many possible ways something can happen. And once you read the situation, you're going to determine if it's a permutation or combination. And then you're going to use a formula to solve those, or you might use Desmos. I'm going to show you how to do it both ways. If you choose to use formulas, the formulas will be given to you on the SOL. Honestly, I think probably most of you are going to choose to do Desmos because it's so easy. But basically what this means is your N is the total number of people in the survey. So like if they say you have 10 people and out of those 10 people you're going to have 3 prizes, the number of people would be 10. So that's the total population. And then your R is how many winners or how many names are drawn, how many people are going on a certain trip or whatever it is. R is that certain number selected. When you have a permutation, then the formula is NPR. And here's the formula, n factorial over n minus r factorial. This is why we had to learn factorials. And for a combination, here's your formula, NCR. So the first number is all your total population always. And the R number is how many prizes you have, how many names drawn out of a hat, how many people go on a trip, so forth. That formula is n factorial over r factorial times n minus r factorial. And again, formulas will be given to you, but most of the time we're probably going to just use Desmos. So there are 10 finalists in a figure skating competition. How many ways can gold, silver, and bronze medals be awarded? Well, first of all, we have to decide, is this a permutation or a combination? Are the gold, silver, and bronze different values? I would say yes. First place gets gold, second place gets silver, third place gets bronze. So the order is important here. So this one would be a permutation. So we're going to use the permutation NPR, and in this case there were 10 finalists and we're choosing 3 winners. So to set this up, it would be 10P3. So to plug into my formula here, it would be 10 factorial, that's n factorial, so 10 factorial over n minus r factorial. N is 10, r is 3. 10 minus 3 is 7. So 10 factorial over 7 factorial is what I would figure out. So I could then go to Desmos, and you see here I get the answer of 720 in Desmos. Or if I don't want to fool with the formula at all, and I know it's a permutation, and all I want to do is set up a permutation and use Desmos the other way, if I know that it's 10P3, watch what I can do in Desmos if I don't feel like using the formula. I'm going to go in here to functions, so I'm going to click functions. And this is statistics, so I believe it's going to be in the statistics place. And then look right here, NPR. I've got NPR. What I do here is my N number was 10. I'm going to hit comma. My R number was 3 because there were 3 prizes. And look what it does. It gives me 720, the same answer. So either way you do it, it really doesn't matter. Either way is fine with me. Again, the formulas will be given to you. What I'm most concerned about is that you're getting the correct answer. You know whether it's a permutation or combination, so you know which formula to use, and that you're able to get the correct answer. This one says a group of 7 students are working on a group project. They must choose 2 students to present. How many possible outcomes are there? Well, we have 7 students, and we're choosing 2 students to present. Is this a combination or a permutation? I would say for this, it's a combination. Order doesn't matter. You're randomly picking 2 students to do the presentation. So this is a combination. And this combination is 7 choosing 2. So if I'm doing 7 choosing 2, I'm going to then go into Desmos. This time, I'm going to go to the functions. I'm going to pick the combination, and this is 7 choosing 2, 7 comma 2, and that gives me a possibility of 21 choices. So this one will be 21. So that's pretty much it for permutations and combinations. These are really simple. It's really just Desmos practice. I want you to go ahead and try these on your own. So pause the video, see if you can get these 2 on your own, and then I'll come back and give you the answers in a few minutes. Okay, so for this one, it was a combination. You had 5 cousins, and you're just picking 3 of them to go get the pizza. So 5 choosing 3 gives me 10. And then here we've got 8 people entering a pie contest. We're awarding blue, red, and green ribbons. So order does matter here, so that's a permutation. And that would be 336 possible combinations there.